Now, what I suggest that we do is that we carefully write invariants. We try to figure out at this point, what do we know about this range? All right? So we probably, by the way, we probably can safely say that this thing should look something like first current IR. But then we need to figure out what's the relation between I current at that point.
First comma I is a sorted range.
First comma current. First I current. I'm waiting for Ian to put current. Yeah? So we know. So let us think about what we need to. What's the relation between I and current before even we assume sortedness.
So there are two ways to do it. One is to say first comma I is the same range as first comma current. That would not be the way we've written it right now, but that would be one way of doing it.
If we write binary insert, it probably means that current is in the ith position.
No,
not necessarily. Maybe it's current is the one after the ith position.
No, because this is the range. Think about it. Let us look carefully at our ranges. So we have the range first, comma, I. It's a semi-open interval, yes? From the point of view, at least from the point of view of upper bound. It views it as a semi-open interval. So the guy in the position I is past the end, right?
Oh, okay, that's what you call position. Okay.
I mean, that's how ranges work. They're always semi-open. Range F0 is an empty range. Range F, comma 1 contains one element, F sub 0. Right? So we index from 0.
And you call it first.
Yeah, you know, don't go there. This is yes, first is not first, last is not last. But we know that this thing is imposed on us with entire sort of universal for all the algorithms. This is what they deal with. So we know that F sub I, and Param correctly says, we expect that this is already sorted. All right? And we probably expect that F plus I is equal to current. Do we expect that? Because this is the guy who we're going to be inserting. So, at least I'm looking at ignore 55 and 56 for a second. Just concentrate on line 54.
also ignore 53.
Oh, ignore ignore all the lines except the commented line 54. Right? So what we want that F comma I is sort. Let's write it out. Could we write it out? Probably line before, after 53, // is sorted first I R. We actually could test this is the function which we have. Yes? And.
That should probably be is sorted in.
is sorted n. Yes, thank you. It's better be. And just well, there is a way sort of doing it. Since we're dealing with, it wouldn't quite work. So the correct way, yes, distance between current and first is I, yes. All right? So that's, everybody agrees that's the invariant on which we rely. So now, thank you. So now, let us see what we need to do. So at this point, what we need to do is clearly, right now I'm just inlining Bird's function. Bird's function is up there with no code. So let us try to see how it will go here. It will be, if this invariant is true, what we could do, we could insert first I, these are correct, yes? We could do in upper bound first I, and we drop plus plus here.
Drop? No.
We're already pointing at the next element.
We're already pointing. If we read this, I'm just going by what we wrote. And then rotate right by 1, insertion point, and it has to be plus plus current. Because we have to move. Oh, since you don't change, you type without even smiling, you know, it's hard for me to see. Plus plus current. Everybody follows? Sort of, because what we did, we found, let us just look. We have this interval, we found the point, insertion point, which points somewhere in this range. Yes? And then we need to take a range from this guy, from insertion point, and past current. So we need to take the range I insertion point and successor of current, and rotate it by 1. It's somehow everybody agrees? Oh, we need to fix all the lines up there because, okay. So now what happens is that we no longer need to change current. Current points past the sorted range here, right? But we need to increment I.
We can't get rid of the plus plus.
Well, we have plus plus. We have plus plus.
Ryan just took it out, put it back.
No. We need plus plus for rotate. Rotate literally operates on the new range. This is moved by 1. Right? But we need to adjust I, which we do.
But
No.
not there.
Not
In line 53.
It's wrong.
Like 57.5.
Yeah.
Because I is already 1 to start, so.
What?
I is
We can
1.
do it there, yeah.
If you,
No.
We initialized I to 1 on line 52.
No. Ignore the. I'm right now just saying let's look from 53 to the end of the loop.
Assuming I was initialized to 0, that would be fine.
Yeah.
At some point, we have to increment I.
And we do in the while condition.
Yeah, that's fine.
Okay. If it confuses you guys, Ryan, drop it from the condition and put the after line 57 explicit increment. Maybe that's easier.
That's completely different. Because you're
Yeah,
using
no,
nine
but-
here.
but it might not segfault that way.
Because you're using
No,
nine
no.
here. If you move it to the end, it's different than if it happens.
Yeah, which is right.
Want it to
The
be different.
variant-
The first time we want to use is 1.
Yeah. First time through the loop, you have one element
Yep.
already sorted.
So the invariant will be true the first time, so that's good.
That's good.
I think what Param was saying,
We actually, right. So now,
initialize I to 0 and put
Yes.
plus plus in the while.
But then we'll be doing an extra increment for nothing.
Oh, wow.
yes, you are correct. But let me tell you, only in terms of academic interest. +1 is free.
We'll also be using plus plus in an expression, which as you've opined before.
Yeah. No. This is better. You're right. But
And then one more change, it could be I not equal to n in the while loop.
I do not see.
Instead of less than n, not equal to n.
Why?
This is defensive programming.
No. But I mean, we do equality for iterators because we have to. But for natural numbers,
But it's the same. I mean,
no, not quite. Not quite. So,
well, okay, it would be if you're,
okay, but right now I'm a little bit unhappy because we're going to do binary insert into an empty range. Yes, the first time around.
I is 1.
I is 1. So the number of sorted, no, you're right, pardon me.
But how can we do this?
Because
We've already plus plus current. If there's one element.
we know that 1 is less than n. So n is at least 2. So the first time through, we're looking at the second element.
Yeah. Yes. Are we brave? Let's ship it. It compiles, runs, and there is a test in the thing. Okay. Let us run till the end. I want to see if.
It's strange that 1/8 is faster than merge.
Yes. That's what I was pointing. Remember that it's sort of catching up, but it's touch and go. It will all change. It's too early for us to do careful fine tuning because we will do so many algorithmic changes before we're done. So, okay, back we go. Now, that should be, you could literally dictate it, I suspect.
So let's just copy lines 56, 57. We'll put them.
Okay, but this is probably going to be called something like binary insert n.
Binary insert n sounds good, and it needs 4 arguments. And I want to. This will be iref current. Or,
What?
yeah, iref.
By ref.
Not by reference. Don't we want to increment it here? Well, okay. You want to increment it in have the caller increment it? That's fine. Current.
Technically, you could return it.
we need to return something.
The signature already has that. So
What should we return? Do we need to, I mean, is there an interesting point to return? No. Explain to me why current is not an interesting thing to return. It passed to us, we know. The guy who called us knows what the current is. Why are you giving it back to him? Never give back something unless you modified it.
Let's return insertion point.
insertion point is also interesting. Yes.
Insertion point is a new information. Again, remember, a person might be using binary insert n totally irrespective of okay? Now, I want to stop for a second because this is, let us return, I mean, we do need to return insertion point, no question about it. That's the thing to return. The point where we inserted. This is a good thing to return. The question is that I'm not quite happy with this function as a general purpose function. I think it's a bit flimsy. It's good for us, but as a standalone guy, he might not be what people want. You see there, or maybe it's the best we could do. Because if we pass value of current, the poor guy will have to move first by n plus 1 by n steps to get to current, which we don't want him to do, in case it is indeed a forward iterator. So maybe it is the final thing. Maybe it is the final thing. Okay? Okay, so this is good. Let us fix this. And now we have a prototype for linear insert. Remember, I mean, all of this thing was we started with a working function. We made it non-working just so that we see how linear insert should be done.
Okay, you have to increment current.
Well.
Yeah.
Down in binary insertion, sort in.
Yeah.
No. We need to change it. We need to delete these 3 lines. Yes, or for those of you who are brave, you could write I plus plus current plus plus here. Only for brave people like
To
me.
remove the increment of current in the binary insert n.
What?
We still need that for the right rotation.
Yeah.
I mean, we need it so that we rotate correctly. Otherwise, we will rotate a range 1 too short. And now we could argue whether we keep braces or not. But I guess we should because we have the invariant line. Okay? Yeah. I'm pretty sure it's fine, but no, it's not fine. What was that? How? What?
Oh, I needs to be in.
I.
Yes. Thank you, Nick. But now we don't have to go to the, I think we could just kill it. Okay. So Bert, since you're in charge, why don't you lead us through linear insert?
copy the signature of binary, insert in, and change it to linear.
Do you need n for linear insert? Why did we need n for binary insert? Because we're going to the half, we need to know the length. But for linear insert, we're going to march down by 1. Yes?
Should we call it backward linear insert?
Okay, so I don't know. Let us wait. It's a good question, but I don't know. We need to look at our requirements. Are these requirements good requirements?
We need a bidirectional.
We need bidirectional iterator.
Still think insert is a bad name. Insert to me, in my mind, is I'm putting something and putting it here. It doesn't say anything about the bubbling action that we're going to do.
Are we going to do bubbling action? Are we going to be swapping? He wants to swap. How many of you want to swap? I mean, since I'm asking this question, they're thinking.
I mean, backward is easy. We already did the rotate we copy the last element and
Yeah, let's do it that way.
Don't need to swap. You save 2/3 of the work. That's a lot. You need to lift this guy and then put the previous guy into the, if you see what I'm saying. Okay, I suggest that do we want to return something? What should we return? What should we return?
the insertion points are still
It's still the same. Again, what is the important sort of connection between these two guys?
they have the same interface and behavior.
Yes, they're semantically equivalent. The difference is only complexity. They don't have the same interface because this guy wants length because this guy just said, I don't need length, so we don't have to match interfaces exactly. But they're exactly identical in terms of its effect. They're going to insert whatever the current guy into the range first current. Let us, by the way, delete 48, 49, since they're utterly useless for it. But let us actually write some invariants. What invariant do you want to keep? Let's assume you have a loop. Why don't you write some loop, like while something or other? What do you want the invariant to be? What is, okay, even ignoring invariant, what do you know about as the precondition? Here. And by the way, there. It's the same precondition. What's the precondition? But important, why would it even work? It is sorted. So let us write the precondition here, and then precondition there. So here the precondition which has to be on which we rely is that first is we have a function is sorted first current, right? R. This is a fine. I mean, we could actually make it into a cert. It's an expensive assert, so we commented out, but it's an assert.
There's one more, that current is
Current is
a
the
valid
reference.
iterator.
Yes. Yes. So, current is a valid iterator, he says.
Wouldn't is sorted imply?
No, because this.
No. This is past there. This is a semi-open range again, where when the world of semi-open ranges everywhere. It's like this is why we write them like that. Square bracket. And we already spent infinite amount of time discussing why semi-open ranges are. So what is binary insert? Just precondition. Sorted. And there is one additional thing which we know. Yeah. I would put it on a separate line or something. But some, yeah. So now we got here, it's sorted. Now we have to. So what is our idea?
Lift the
Temp equal to start current.
Temp equals start current, and then, well, previous is,
Okay, let us try. So do we lift it outside the loop or inside the loop? Outside the loop. He wants to lift it outside the loop. You have to write the horrid thing. Let's see if he could write the horrid thing. Type def, type name, yeah, the horrid thing. No, it's only one thing. Angle bracket I call value. And let's call it T. And then value temp equal star current. We lifted it. Now, we need to figure out while something or other and something or other. We do something or other.
While R minus minus current.
R.
yeah.
No, wait. First is also, yeah, there.
Ah, see, there are two conditions which we need to be sure.
So I'd say just let's subtract outside the loop. We can do that, yeah. Because first, no, then.
So one of them is while value.
Let's write, let us ignore the beginning. Again, guys, this is what I always sort of assume there is some code here. But then let's write the loop. Always start with, again, start with inside. So we probably want to sort of write some invariant. If I
First is not equal to current.
First is not equal to current.
Oh, invariant.
What?
No, why don't I was just suggesting things.
Yeah? Bert, you go.
Are we writing invariants or code?
Whatever you like.
Let's try to write the code.
He wants to write the code. Let's write the code. Since he got the spoon, let's let him.
So, wow, yeah, sure. Well, first is not equal to current, and R of value, comma, start we'll have to
current
fix something.
itself?
We'll fix that later.
Don't we want to start from first?
Is it the correct direction?
If we don't go backwards, we
Yeah,
can't-
we're gonna
we
go
can't-
backwards, right.
Yeah, you,
We're gonna decrement current.
you are going to decrement current. But right now you say you want to move while value is less than current.
Yeah, swap those. I want to,
So, no. Do you, to assure stability, what do you need to do?
I want to move while value is greater than current, start current. Greater? No, less. Yeah, I want to move while value.
And for equal guys? For equal guys, you do not want to move. Okay.
So yeah, so what I had was what I meant.
That's correct.
Yeah.
Let's
Alright,
do it.
so let's
we need
put
to,
a
we need to move current back.
Current
Minus
minus current somewhere.
Which even now makes it a little bit so that we have to assure some relation between first and current, which would allow us to do this. But let's not worry about it.
Yeah, first equals current.
Semicolon.
And then decrement current inside the loop. And let's see, we have to assign something.
You can't do that either.
We can't.
Well, actually, no. You can.
Start.
Yeah, we can keep decrementing current.
We know it's
but
not
We want-
first.
Yeah.
So
Start
okay.
current equals.
That you need to move current someplace. Somebody should be moving, guys. That's,
I think we may need a second iterator.
I think what we have to
previous
do
and a
is-
current or something, so that we can.
you could do that, or you could rely on the following conjecture that plus minus 1 are free.
Yes. It's like doing with arrays.
It is, let us write it, then we will see it. So what do you need to move? You need to move the guy who is in a current where?
To the
Logically,
Backwards.
to the right.
Right.
to the right, not back. I mean, backwards to the direction you're going, but it's actually forward to the back of the collection. Whatever, to the back of the collection. So, just, I would think that star success of current equals star current, we'll just do it. One would think. Here we're relying on the fact that somehow success is free. Otherwise, we need to introduce your trick.
And then at the end, we need to put value. Oh, no, we don't. I was going to say.
So we have to put the value
We
in
have to put
current.
value back. Yeah. We need to start current equals value.
And then, of course, we need to return current. That's where we stack the value. And then, of course, we have to make it all work because I maintain that both of them are not quite correctly specified in terms of what are the preconditions. Which would, because observe, like here, you are bravely dereferencing current. Nothing in our precondition, but if you go up, we didn't write it. Yeah, we did. I was asleep. My apologies. Okay, so current is a valid iterator. So, yes. Okay.
But that doesn't mean we can decrement.
Doesn't it?
No, it could be equal to first.
It could be equal to first.
But then we check. Oh, you can't even decrement.
We cannot decrement.
So if first equals current, then
Just return.
just
Okay.
return.
If first equal current and first, it's still not enough, is it? Yes, now it is enough. But this we don't need to do because, no, because this is not precluded. It could happen. It could happen because if somebody gives us a range with one element, yeah? No.
I mean, if the value is less than the first, we're going to fail.
No. That we don't check. We never check because that's, you know. We always assume that people give us valid ranges.
No, but if
If you have,
this code is never going to change star first. And
Right.
sometimes it should.
You can't insert in the first position.
You cannot insert in the first position. That means we are in. Yes, it will insert in the first position. Of course it will. Line 60 will insert in the first position.
What's line 60?
Oh.
Well, there should be a line 60 there. Yeah. Line 60 will.
Insert in the first position, but it won't have copied that element to the last position.
Oh, it doesn't. We don't need to copy it in the last position.
Yeah. Okay.
If you're given if
Oh,
first
yeah.
points to a range that's one element long and that element is 2, and current points to 1, the value 1.
What are you talking? Let's look at the example.
He's saying you're passing 2, 1.
2 comma 1. Okay. Let us see. So we have 2, 1. So current points at 1. First point at 2. We save. Yes, this is clearly not going to work because we're. We need to move, yes, this is incorrect.
we moved the element in 57.
We move the element in 57, but if this is true, we never get to 57. If this is false, we never get to 57.
Because then we can separate the.
You can fix it by moving the first is not equal to current as an if statement after you do the move. After you do successor current is equal to star current. You have an if statement that breaks out of the while loop.
And then fix line 60 to also.
This is a good idea for some other reason which I will disclose later.
Here?
I think so, yes.
First equals current.
that? Is that what you're saying?
I think so.
Yeah, that works.
Guys, I apologize. Could we take a look at some other code? Just could you go to a directory called documents F4 performance course, and the file is called insertion sort. By down, up, 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 up. No, we want to not unguarded up, up, up. Where is the thing, the thing called linear insert? Oh, I see. You're not supposed to see anything here. We'll get to that probably at the beginning of next lecture. Sorry, my apologies. Or maybe we'll get to it now. Okay, so what we want to do now is to quickly write insertion sort and test whether the thing works. Write insertion sort, not binary insertion sort.
Just make a copy of the entire binary
Yeah.
insertion sort and function. Change its name.
So you change forward to binary, to bidirectional. Or just linear insertion sort, yes. It's nice to keep this in the same interface because then we could plug it into, except we don't need I there. Okay, and what we want to do, we want to go to our insertion sort test driver called test insertion sort, and we want to do this, and we want to see if it works. What happened?
It's down inside the.
Why there is no underscore? Or here. Yes. Sorry, guys. It's sorted all right, but okay. So obviously it's not working. Okay, let us go and see why it's not working. I suspect that the only culprit could be the linear insert, since there's literally nothing else in this code. So what we do something wrong. So if first equal current, return first. The thing is one element guy, he's already sorted. Otherwise, we are saving current. And decrementing current. And we're saying while this guy is less than whomever lives there, we're going to move the current. If there is no other place to move, we're done. Otherwise, anybody sees a bug? And we know what we do is somehow we're losing an element. If we look at the results, it means that we are, at least in one case, we're overwriting the element which we haven't shifted, which should never be the case.
Look at
So
the
we
code
don't
again.
shift the 5, we just put the 2 on top of it.
And that is the interesting question. How could we,
When we come out of the loop, current is not less than value.
We haven't
Current is
saved
pointing to
current
the
yet.
thing that we don't want to move.
So we don't want to put value in current. We want it in current plus 1, right?
No. Current plus 1, we moved thing from current to current plus 1.
After we exit the while loop.
And then we decremented current. That's the problem.
And then we decremented current because we could.
But now current is pointing to the thing that we didn't want to move. So we have to, in 61, I think we have to say successor current equal to value.
If we exit the while loop through the while condition, we move current too far. We're now pointing at an element that is greater than the one we are going to put in its place.
Very correct. So what he is saying that in this particular case, the whole, we know that the whole is at current. So we need, okay, so let us try to make a simple fix. So here instead of break, you write brace. And how do we could easily fix? We could easily fix, since we know, we write exactly that, current, whatever, the line 63 and 64. Because at that point, they are correct lines.
But the problem was,
We will solve the problem.
We need a condition to get us out of that while loop.
No. And return the line 64.
Return?
Return current.
Return current.
Return current.
okay, in line 60, outside the loop,
And here, if we got out of here, this is Hernan's point, we actually, the whole is ahead of us.
we overshot it.
We overshot it. So what we need to do now, we could just say plus current. Just move it back. Since we overshot it.
Okay. Because then we want this.
We want to return it to.
Just put it on a separate line.
Do we believe this fixes the problem? Yes. It's looking a lot, very messy. Yes. but at least it might be correct. Let us test it. Yes, this is utterly unacceptable as the final result. But it works. Guys, this is the problem. Not everything which works needs to be shipped. So this, and let us look. So it clearly looks awful from my point of view. Yes? So we have two tasks, and since we are getting to the very last point, I want to tell you what we need to do, because if I tell you a little bit further ahead, it will help us to fix that. Let us go back. Could you show us this linear insert? This linear insert is also, how can I put it? It's excessive in terms of doing work. It just does too much work. What could we cut? Nah, this is nothing. I'm not worrying about plus pluses. I'm worrying about serious stuff which does affect performance. Things like conditionals inside inner loops. This is a bad guy here. He's a bad guy. He breaks the pipeline right there. Is there a way we could get rid of him? Yes, please be my guest.
Okay, so right now, we're going from the back,
Yes?
right? Why can't we go from the front? We have current, we extract it, we find the insertion point from the front, and then it's just copy and put it there.
Okay, anybody wants to explain it?
Because that might be far away.
But how do we know that the back isn't far away?
Back is not far away. We are insert. Remember that what we know is that the guy is close to where he is. Right? We already have the algorithm which does what you want, quite optimally, by the way, because it uses binary search. If you're going to look for the whole thing, okay, I'm inserting a guy, I reached the point 1 million. If I want to find where to insert the guy number 1,000,001, the best way at least to find insertion point is obviously binary search. Do you agree? And we've done all of that. We have something we're quite happy with, remember? With binary insertion. If, however, you say, let us do linear insertion from that end, you're going to march basically probably all the way to the million before you, or somewhere around, before you find the insertion point. You're going to do lots and lots of work. Right? Now, it's a good question, because it's very tempting to say, you know, we sacrificed, remember we sacrificed, we now require backward direction move. This no longer works for, but we have a good stuff which works for forward iterator. We have binary insertion sort, it's good. But now we're trying to say that there are cases, remember again, sort of this is the core point, that there are situations where when you reach somebody, we know from some other considerations that he's not going to move far. That's why we're using linear insertion, precisely because we know he's not going to move far. If we start here, we know from this very consideration he is going to move very far. But, okay, so we need to work on, I mean, we have a bunch of stuff. This is, while it compiles and runs, it's unsatisfactory. But I'm trying to tell you the other, I mean, since Hernan probably wants to solve all the problems by himself on Friday, he usually does that. Param is going to help him. Let me just show you which direction you want to think. Let me, Okay. The direction is that this is truly a troubling thing.
But we only need to check that at the very end.
You cannot check it at the very end because that you don't know when. If I knew where the end is, of course I would be checking. But how do you know? You don't know. No, I mean, it's like you couldn't be driving with your eyes closed saying that I need to open them only when I'm close to the traffic light. I mean, you have to keep them open all the time. Yes. Yes. You want, did you? Sentinel. It's a good thing. What you said is a good thing. That's what you wanted to say?
I was going to say it a different way. I was going to say it would be nice if you could figure out a way to force the one comparison to, to for sure.
Yes. So let us assume that we never, ever need to insert it in the first place. If we could come up with a thing like that, then we could throw this piece away completely. It will become so much nicer because we will be just saying, somebody will stop us before we run off the cliff. I cannot tell you everything, but the idea, how could we do that? Anybody knows how we could do that?
Start first is equal to start current.
No, this is a bad idea. You're overwriting something.
Copy first,
Yeah.
but I don't like it either, but it
No,
will
no.
work.
The problem is that what you want to do, if you do that, you have to do it every time when you do insert. I don't want to do it every time. I want to create a permanent sentinel, which is good forever. Who could be such a sentinel?
Well, if you put the check, or if you compare first and the current value before the while loop, you can guarantee that you'll have a spot for it.
No, because it's
We find the successor first
and
use that as our.
no, but then you still do the comparison every time.
But we don't care because if we go past it, that's okay.
No. You are saving these two different paths, but that is not an issue. This issue is of no consequence. The issue is inside the loop you're doing this compare.
I'm saying moving the compare back up to the top of the while.
It still will not help because you will be doing, whatever you do, you're going to be doing two comparisons. Even if you manage to write it with the help of AND, which we will, the problem will remain. You will have, how is wild compiled? Do this, it's still a problem. What?
Test first, and if you know.
Yeah.
No.
Before you go to get to the while loop, check to see if the first is less than your current.
That you have to do every time.
No, only before you enter.
But for every insert, you will have to do it. What I'm saying is, why not create a permanent sentinel, which we do once per sort?
So change the function name to linear insert with sentinel, and ask the caller to put it there.
No, but we don't want the caller to do it. How could we do it? I'm overrunning, but let's assume it's all right. Just let us figure out. What if I have a sequence of n elements? Does it have a natural sentinel?
Min.
Yes! Minimum element is a natural sentinel. Do we have a way of finding minimum element? We have a function. We have a wonderful function, min element, std min element, which we implemented.
current is already sorted, so star first should be.
No, not in the sort. The outside.
In the sort, you come to the sort, and you say, first of all, I'm going to do, let me just suggest something. What you do, you say, I'm going once and for all to figure out who is going to be in the lowest place. Could I do it? It could be done with how many lines? One line. It is literally one line. Because what do? You say std swap, star first, std min element, first, last, or whatever.
And then you're no longer stable.
How is it I'm no longer stable? Absolutely. Oh, he is correct. He is correct.
You have to rotate everything.
He is correct. He is correct. I'm no longer stable.
Why isn't it?
He's moving star first to some random place.
Min element will be perfectly good. It's the star first which will be Okay, guys, you have a lot of things to think about. So do I. So we have to figure out what we will see that the Sentinel technique actually does work. But what I just suggested, of course, doesn't. Think about it. All right? So you know what to do. You know what to do. Okay?
So with the right shift by 1, would you actually implement it the way you wrote it, or because that does do 3 assignments per?
Only, don't worry about it. And this is not, we are not going to do this algorithm for forwarded relators anyways. So this is not an issue. Just couldn't get there. But thank you. Could we look at this file again? No, you guys don't look. I want to look. See you.